Yes, you're most welcome to this lesson. It's going to be for Senior 3 Mathematics. And my name is Masava Erisa. I work with the Holistic E-Learning Platform. I also work with Mbale Secondary School, where I teach mathematics and ICT. I'm so happy to be here, and I want to congratulate all of you for making it to Senior 3. The last time we interacted, you were in Senior 2, all of you. I remember most of the names here when you're in Senior 2 for mathematics. But also when you're in Senior 1, I can't wait to hear from those people that I know. We are going to give a volunteer to give us an opening prayer. An opening prayer. When we give you a chance, please mention your name and the school where you're coming from. That is a very golden opportunity for us to at least know you, but also the whole class. Give us an opening prayer. Pray so well. Make sure you're loud and clear for everyone to hear. And maybe before we get the opening prayer, please rename your devices such that we can call you by name. We are going to use the chat at some point for typing questions, but every time you are asking a question, please put up your hand. There is a person using Samsung A05. Your hand is up, but again, I don't know your name, so I wanted to give chance to a person to give us an opening prayer when they've renamed their gadgets. Yes, Lynette, you can proceed. Your name and your school, Lynette.
Your microphone is unmuted.
Yes, Lynette, proceed.
I'm from Rorogota City Secondary School in Isinjiro. Let us pray as we humble ourselves. Dear Lord, we thank you for this day. We know we have sinned in whatever we have been doing throughout this day. So we pray.
Yeah, Lynette, we can't hear you. Lynette, unfortunately, we couldn't finish the prayer with you. Can we get probably Keira to complete that prayer? Keira, please start from where Lynette had ended. Keira or Manuela. Manuela and Keira, who is ready, open your microphone, please.
Good afternoon.
Good afternoon, Manuela.
My name is Alitua Manuela Karen. I go to Gayaza High.
Okay.
Dear Lord, we thank you for this day and for the gift of life, of Father in heaven. We thank you that you've brought us here today. Thank you for the lessons. We thank you that you've enabled us to finish the whole week, oh Lord, while we are studying. Lord, we pray that you may help us to be attentive, oh Father in heaven, and may there not be any sort of distractions to distract us from the lesson, oh Father in heaven. Open our brains to understand everything that is going to be taught, and may we hear every single thing, oh Father in heaven. We pray that you may use the teacher and bless them to teach us well so that we may understand all the concepts. In Jesus' name I prayed and believed. Amen.
Amen. Thank you very much, Manuela, for that wonderful prayer. And yeah, so glad to have someone from Gayaza High School and specifically giving us an opening prayer. I want to welcome all of you. And like I said, my name is Masava Erisa. I'm going to be your teacher this afternoon for mathematics. I'm going to take you through the basics of what I feel you should know this afternoon. And I pray we cooperate. I work with Mbale SES. We be here in Mbale. And I work with the Holistic Learning Platform for now some time. For those who've interacted, you know, this voice must be familiar. As usual, I'm going to give chance to two people to say hello to class officially. You tell us your name and the school where you're coming from. Make sure when you put up your hand, you have a good network. Let people hear you so well, where you're coming from, the school where you're going to, and probably a word of encouragement to the whole class now that this is our last lesson for this week. Scott, let's start with Scott. Scott, please go ahead and give us your introduction.
Yes, good afternoon, guys. I'm from Gayaza High School. Yeah, that's my introduction.
Okay, you're welcome. You didn't tell us your name?
My name is Scott Mwesigwa.
Okay, you're most welcome to Mexico. Read for us the people that side when you go back. Then the next is Ivan. Ivan, please go ahead and tell us who you are and where you're coming from.
Ivan from Exodus College, Awakiso. Thanks for having all of you here today. Have a nice one.
Ivan, which school? I had Wakiso. Which school is that?
Exodus College.
Okay, you're most welcome. Great for us people from Wakiso when you go back. I want to give chance to two girls also. Let's start with Prissy. Prissy, hope this is Priska. Prissy, please go on. Prissy, if she's not ready, we pick Isabella. Prissy, if you're ready, please talk to us, or I give a chance to Isabella. Isabella, please go ahead and make your introduction.
Good afternoon, everyone. My name is Isabella, and I'm from Mount St. Mary's College, Namagunga.
Mount St. Mary's, Namagunga. Yes, you're most welcome, Isabella. It's great for us, the people in Namagunga, that side. Prissy, I gave you a chance, and I'll give you the chance again for the last time.
Okay. Hi, guys. My name is Nakalima Priscilla from Budini Secondary School.
Budini. Budini? Budini, yes.
Budini.
Here. Okay, here in Ginger?
No, it's in Kalilo.
Oh, Kalilo. Yeah, there was a district confused. Yes. At least we have at least someone from Kalilo. Just not very far from Bali. Yes, you're almost welcome. I'm going to lower all your hands, and I pray that at the right time, your hands will be picked for those who want to say at least something. Please put down your hands such that we can now start the lesson. Everyone, please, if you had put your hand up, kindly put it now down such that we can start the lesson. Okay. This is going to be a math lesson for those who are just joining in. And before we start, allow me remind you of the senior two topics that you could have covered in places where you're studying from. And of course, I can't guarantee that all of you have finished, but this is what we expect schools to have covered. And please look through the topics. There are 13, and you're going to go in the chat and type and say, we've covered 13 topics. We've covered 12. Count them, count the ones you've covered, and write them in the chat. And you write and say, for example, I'm going to write and say 12. Then you put space and put Mbali says. That means at Mbali says for us, we've covered 12, something like that. Count them, count the topics that you've covered, go to the chat and write and say, we have covered 12, like that. I had deliberately closed the chat and I'm going to open it. Of course, when your answers are ready, then I want to hear. Please count, go ahead and count, then get ready to write in the chat that we've covered this at this school. The chat is open. Yeah, maybe let me open the chat now to everyone. I want to see out of the 13 topics, Your school has covered how many? No one has written in the chat yet. People don't know where the chat is. Stiki Mutumba. Okay, they've finished 13. Stanley, that is good. Equatorial College from Victor, 13. Good. We covered all. I don't know the school. The person who has said we've covered all. Exodus, that is Ivan. And the Ivan is from Wakiso, 13. Good. Rubidia says 13. Budo SS 11. Yes, you're good to go. 12 from St. Mark. Then we have 10 topics from Bologoto Seed. Lynette has told us they've covered 10 topics. Lynette an opening prayer from Mfungiro, but we didn't put the prayer. Then Budini. Dean has told us they've covered 13, and Taiba International, they've covered 13 equally. Manuela is confirming that they've covered 13 from Gayaza High School and many others. I'll close the chat at that point. Some people have 13, some people have 13, others have 11, and so on like that. Yes, we will probably assume that in your school you've covered all, and if you've not covered all like some other schools, please, the teachers, I know they are going to work around the clock to make sure they cover all these topics. Yes, at Mbalises, we've at least covered all these topics, and I pray that in your school, if you've not covered, when you go back, you cover them very fast. Now, at Holistic Learning Platform, yes, this is your fifth lesson for those who started on Monday, and this is math. The next math lesson will be on Friday, same time. What do we do at Holistic? We want to make our students who interact with us at the Holistic Learning Platform the best in whatever schools they are coming from. If you are at Gayaza School, when you are with us at Holistic Learning Platform, our main idea is that when you go back to Gayaza School next term, which is starting, you become the best. When you go back to Udin, you become the best. When you go back eventually to Insingiro, you would be the best. So what do? We always pick the topics that the students are expected to study in that next term, and we interact with it at length with the students, such that you have a feel of what you're going to study in the next term. And your next term is first term of senior theory. Allow me display what we expect you to study in senior theory. Please take a screenshot. Here is a list of 9 subjects and 9 topics that you're going to encounter in senior theory. And specifically, we are going to concentrate on term 1. I have not added term 3 because now that makes it 13 topics, and you meet them along the way. So what happens here is that at Holistic, we look at the topics that the students are expected to cover in the next term, and we see which one can we start with for students to benefit when they go back to their schools. For schools that have not finished the 13 topics, we are going to introduce the new topic in senior theory. So when you go back, the teachers will cover the remaining topics. Then when they introduce eventually topics of senior theory, you should be a star. Let them know you're coming from the Holistic e-learning platform. And the topic that we are going to pick is going to be equation of a straight line. And it is coming from the theme of, the theme is from patterns and algebra. Patterns and algebra. This is not going to be your first time to interact with patterns and algebra. Allow me take you back to senior 2 and see what happened while you're in senior 2. In senior 2, the topics that were under patterns and algebra, let me sample senior 2 second term. Patterns and algebra, we had topics like inequalities and regions. We had algebra. We had we had algebra, I think. Then in term 1, you had mappings and relations and so on like that. Now, those are about 6 topics in patterns and algebra. Now, when we introduce equation of a straight line, this topic is going to be added on patterns and algebra theme. Remember, when they are setting your end of year assessment, or maybe you're going to do UNEB, which you're going to do next year, of course, your semi-candidates, they set for you 4 questions, And each pattern, they combine all the topics that are in that pattern to give you one scenario. So under patterns and algebra, go back to your books and count how many topics have I covered, such that when you're revising, you know that under patterns and algebra, any question that come in this area, I can score it highly. How do you do that? Please go back and start to look for all the topics under this theme, put them down. Topics under geometry and measures, put them down, and so on. Then when you get to your end of year exam, you'll be so good because they will give you 4 questions, and we have only 4 themes in mathematics, and those 4 themes is where the 4 questions come from. So I'm going to take you straight to equations of a straight line, and the theme is from patterns and algebra. So I wanted to interact with you and see what technology from primary. Is there anyone who has an idea on this topic? You share with us. It is going to be topic 1 of senior theory. Please take a screenshot, tell your friends that for us we've already joined senior theory and we're already studying the first topic in senior theory, which is equations of a straight line. And the theme is patterns and algebra. I want to give a chance to one person or two if you already have an idea of patterns, on equations of the straight line. Tell us what you know about the equation of the straight line. I'm also opening the chat such that whoever may not get chance to say it on microphone, you can write it in the chat. Can I have the hands up? Is there anything that is familiar when we talk about equations of a straight line? I'm waiting for the hands. No person's hand is up. Please put your hand up and tell us at least something that comes to your mind when it comes to, yes, Glenn, if that is how they pronounce your name.
The main equation is y equals mx plus c.
Y is equals mx plus c. She has told us that when we are dealing with equations of the straight line, we are going to deal with an equation that is y is equals mx plus c. And this is the standard equation of the straight line. Glenn has already told us, and that shows that she has some knowledge about this. Any other person with an idea? Eminem? Any other idea? Yes. Eminem, please. Or I pick Techno. J5. Techno? Yes, the person using Techno, tell us your name. I help you rename the site. What's your name?
Bogar Evelyn Agnes.
Agnes?
Yes.
Yes, Agnes, proceed.
What I know is that the equation of lines cannot change wherever the point of the line.
Yes, if you have, that is good. Thank you, Agnes. If you have a straight line, and I'm assuming this is point A, and this is point B. If this is point A and this is point B. If this is point A and point B is there, Agnes is telling us that this equation of the straight line will never change. Even if you tested it at this point, even if you tested it at that point, the equation remains the same. I think that is good, Agnes, and I'm surprised you know that, and it is, once you know that, then you're not in senior 3, you're almost in A level. So can't wait to see how your performance is going to look like in the activity that I'm going to give you in the end. Yes, Ivan, what also do you know about this? Ivan is from Kiso? Yes. Ivan, please go on.
Yeah, just adding on the first speaker.
Yes.
And is in the format of y equals to mx plus c, where y is those are the numbers that are found on y-axis, and then we have m, which represents the slope, and then x is the value of numbers that are on x-axis, and then c is the constant, and it's always constant, like does not change. Yeah, that's all I know right now, Papas.
Yeah, you've told us that is y-axis, and you're telling us this is the m is what? What did you say about m? Gradient?
Yeah. M is the gradient or the slope.
Or the slope, slope.
Yeah.
Then you said the x, these are values found on the x-axis.
Yes.
Yes.
And then C is the constant.
C is the constant, correct?
All right.
Yeah, he has also given us what he knows about this equation. He has just added on what the first presenter told us, that the equation is that he has come in simply to define the terms. Keira, please tell us what you know.
I think that a straight line equation shows how one quantity changes when another changes.
Beg your pardon?
I think that a straight line equation shows how one quantity changes when another changes.
Yeah, she has told us about the change, and that is good, Keira, and it's good knowledge. If I get to know you know that, that is good. And when we are talking about change in mathematics, we use this symbol, and change in a quantity like y will represent it with that, and change in a quantity like x will represent it like that. So yeah, she has told us how the changes will look like, and that shows that she has an idea also, especially when it comes to the gradient. Okay, we will not take long on that. And I don't know where they are. I don't know. Try that arts room. Okay. Please put down your hands such that we can proceed. So, with the knowledge that you've given me, I have a feel that most people here have interacted with this topic, and I really can't wait to see your feedback when it comes to the tasks. Now, we are talking about the equation of the straight line. They've told us about the slope. They've told us about the change and so on. I have an activity here which has been written from the general knowledge, what you know. You don't need math to understand this. The task is here. Someone should put up their hand to read for us before I display. And the person going to read for us, you tell us your name and the school where you're coming from. Trish, this is another hard name to pronounce. Please tell us your name and the school where you're coming from. Is that Trisha? Is that how they pronounce?
Yes.
Which one? Which school is that, Trisha?
From St. Mark's College, Namagoma.
St. Mark's
College, Namagoma.
Okay. Read for us this and help us understand what it means.
Okay. If you're walking up a hill in your village or climbing the stairs, what makes one path harder than the other? What I've understood from this question is that it's requiring us to know, like, if you're walking somewhere, what is making your journey harder, by either climbing the stairs or I even don't know.
But you seem to have explained it well. Read it again. There are two tasks. They're talking of two scenarios here. One is talking about climbing a hill in the village, and another one is climbing mere stairs, maybe in an apartment and so on, or at a school.
Yes.
There are two scenarios here. Explain them now. What is the task saying? What makes one path harder than the other? try to explain it again.
Okay. To my own understanding, they're asking us, if you're climbing a hill, which challenges do you face? And if you're climbing the stairs, which challenge do you face? And which one is harder than the other? And to my own understanding, climbing a hill is kind of harder because it requires a lot of energy for one to walk, and more than another person who's going to climb, which is whereby the person does not use a lot of effort, unlike the hill. That's all.
Okay. Yeah, that is from St. Mark's College. Found it very fun here. Just try to explain, and she has also read for us the scenario. Any person who can give us this answer, what do you think makes the path harder? She has already taken her side, and I think she's right. Climbing the hill is harder. Actually, that is a hard challenge. But climbing stairs, you can't even feel. Before you know it, you've reached up. What Trish has told us that climbing a hill is harder. What really makes it hard? Anyone can try to explain that by show of hands. Charity, please go ahead. Charity, please tell us what makes it hard. Okay, I think Charity is not ready. Let me give chance to Matthew. Matthew, please proceed. Matthew, we can't hear you. Much as you're speaking, I can't hear from this side.
If you're walking up a hill, what makes climbing up a hill harder is that a hill has a wider area space than the stairs.
Yeah, the wider area space. Okay, let me write it down. I may forget. Wider area space. There is a picture I tried to generate here. Let me see if I can maybe use it before Matthew goes off the microphone. There is a picture here. I wanted you to focus on the hill in the background of this picture. These are stairs. Focus on the hill, the other side, climbing this hill in the background and climbing these ladders. Assume one of it is in the village. Of course, the other side is in the village. This side, maybe it is town and it's a good home. They are climbing ladders and so on. Focus on the hill, the other side. And Matthew has told us that because of the surface area. Matthew, what did you say?
The hill has a wider surface area than the stairs.
Wide surface area. Yes. The reason why it is hard to climb a hill is because of the wide surface area, according to Matthew. Thank you, Matthew. Any other person? Let me see. Romans, please give us your answer.
I feel like it's because the hill is more steep than the stairs.
Steep. Yeah, it is more steep because when you're climbing a hill, you go so high. Still, it's to do with that. So the stairs are not steep.
No, they are, but they're built in a way that they are not that steep, unlike the hill, because the stairs are built and then the hill is just plain.
Okay, you're trying to mean whenever they are making the stairs, there should be some standards they follow. Otherwise, for the hill, it is just nature. I think that is what you're coming up with in your mind.
Yes.
It's nature. Yes, steepness is a good idea. Ivan, tell us what you think. What makes it high for you to climb a hill than when you're climbing stairs?
For me, basically, what I think general that activity maybe requires us to know the concept of the gradient, and all I know, the more the gradient is slanted. That's the more you find difficulty in walking uphill. So when you look up behind, when you
Slanting,
look,
or did I hear slanting?
I said slanting.
Okay.
Yeah. So when you look on the stairs that the ladies are on, yeah, they're slanting, and that one brings out the concept of the gradient. And even the uphill behind, it's also slanting, bringing out the concept of the gradient. So it is much easier to walk on a flat surface because there the gradient is not so much slanting compared to that uphill where the gradient is so much slanting, and you may find difficult in walking. That's all I can say.
Okay, I think that is a very good summary. When the slant is too high, which is called in slanting, or the gradient, it is a bit difficult. Imagine that hill you're seeing the other side, and you're walking there. It is so high, and I'm assuming it is steep to reach up here. But when you're climbing the ladders, maybe according to him, the gradient is a bit not so big and slanting a little bit, and that's why you can't feel a lot of difficulty. I want to agree with what Ivan has told us, and what this guy from St. Mark's College also told us, and also the other one who told us about the wide surface area. Now, what happens is that when you're climbing a hill, it is too steep, and it's difficult to climb when it is too steep, like Ivan has said. And when it is a ladder, there are standards they follow. They have to look at the steepness. They can't make a ladder too steep, makes it very hard for us to climb. And this concept is going to help us when we are in this topic. And this is just one of what we'll look at, and that is called gradient of a line. If maybe you draw a line from here, the one that is too steep, we shall say the gradient here is too high. If it is not, then say the gradient here is not very, very what? High, or like see. And the next activity is here, and it is talking about a ladder. Now you will take some small time and look into this ladder. Please look at that ladder and use it to answer this task. The ladder is here, and it is 10 meters high. This ladder is 10 meters high, and from the wall where this ladder has been put is 2 meters. So is this ladder steep when you're climbing it, when you're climbing here? Is it too steep or it is not? And if we want it not to be too steep and so on, if you don't want to feel difficult, what do you do? The task is here. Please read through and give me the answer. The activity is there. Okay. Sorry for delaying, but we have some hands up. I know they must have the idea. Please, when you're giving your answers, try to explain your answer to make the whole class understand why are you doing that and what do you intend to solve in that process. There is this new hand that I've not heard from. Is called Lil Bank. Lil Bank, please tell us your answer. You were the first to put up the hand. Lil Bank, you're using an account called Lil Bank, or else I give the chance to someone else. Okay, Lil Bank seems not to be ready. Let me hear from Shanice. Shanice, please go ahead and tell us your answer. Shanice. Shanice, are you ready? Okay, if Shanice is not ready, I'm putting down everyone's hand. The person who is ready, put up your hand first. Please go ahead, put your hand up. Keira, please give us your answer.
Okay, so I think that if the foot is 8 meters away from the ladder, okay, 8 meters away, the ladder lies more sideways, so it's less steep. But if the foot is only 2 meters away from the ladder, it stands more upright, so it is steeper. I think this is because when the bottom is closer to the wall, the ladder has to rise more vertically. When the bottom is further away, it spreads out more, and I think it doesn't rise as quickly.
Is this what you've said? 8 is less steeper? Is this what you said? Keira, did you close your microphone? Okay. But at least I heard when she was telling us 8 meters is less steeper, and she has explained it so well. And when you put it 2 meters, it becomes too steep, and she has explained it very well. Can I hear from someone else if they have maybe a different view? Santos, please tell us your view. Santos, please tell us your view. If Santos is not ready, I want to give the chance away to a person who has not spoken here. Jonathan, please tell us. Jonathan, please open your microphone. You're speaking, but you can't.
So, according to me, when it is 8 meters, yes, it is less steeper. This is because it is less vertical. So, meaning it's about to become horizontal. So, it's easier to what? To climb. So, meaning it is less steeper. Then, if it is 2 meters, the distance between the ladder, if the bottom is 2 meters, the distance between the ladder and the distance between the wall is reduced. So since it is reduced, it means that it is steeper because of that reduced distance, making it steeper than the 8 meters, than the bottom, which is at 8 meters. So, meaning if it is at 8 meters, it is less steeper, and 2 meters is steeper because of the distance that is reduced between the what? The bottom of the ladder and the wall.
dropping out, but he has explained it so well.
Yes.
Maybe the last person to wind this up. I was going to Jonathan. We may not get back to Pablo. Have your say, please. Thank you, Jonathan.
So,
Pablo, please.
so the question is, imagine you have a 10-meter ladder leaning against a school wall. If the foot of the ladder is 8 meters away from the wall, is it steeper or less steep than if the foot is only 2 meters away? So if we use math with this question, we're going to find out that this question can basically need the knowledge of Pythagoras theorem. So for the case one where the foot of the ladder is 8 meters away, originally, yes, the ladder is what? Is the ladder length is 10 meters, meaning that's the hypotenuse. The height of the wall is not given to us. Then the distance of the ladder from the wall is the 8 meters. So for us to find the height, we're going to use the normal method, a squared plus b squared is equal to c squared, whereby after all the calculations, you find out that if the distance of the ladder from the wall is 8 meters, the height of the wall will be 6 meters. Then for the second case where the foot of the ladders is 2 meters away, we are going to find out that the A, which is the base, is 2 meters. The C, which is the hypotenuse, is the 10 meters. Then for us to find the B, we're going to use the A squared plus B squared equals to C squared, whereby after all the calculations, you find out that the 96 has no direct square root because that will be 100 minus 4. So the 96 has no direct square root, which is approximately 9.8. So the ladder is less steep when the foot is 8 meters away and steeper when the foot is 2 meters away. Yes, thank you.
Okay, I think that is a very good and wider explanation, and I'm happy that you had to use the formulas to arrive at that. But to a layman, when you look at this ladder, when you push it backward, it becomes less steeper, and even a child can climb and walk easily. But when you push it to the wall, it becomes more steeper. And the steepness here is what we are referring to as the gradient of a line. You remember when someone talked about the steepness in the previous activity of climbing a hill and climbing the stairs. The steepness is what we are concentrating so much here. And you realize that if you push the ladder to the wall, it becomes too stiff. If you bring it this side, it is a bit it is less steep. That is the mathematical term we use here. And lastly, maybe to wind this up before I introduce what we are to talk about, is this particular activity that is talking about a rain. Of course, look at this person who constructed this house. Has made this iron sheets. Is this roof steep or slanting? And what is the effect of water? If it is steep, what is happening? Can someone explain to us this picture in terms of steepness? If you make it steep, what happens to the water that is dropping down and so on, or anything that you can explain about this picture using mathematics, especially steepness or gradient or anything to do with the roofing of this building. Please, I'm lowering your hands down because some of you could have forgotten the hands up. Please put up your hand if you want to say something about the roof of this house. Yes, Agnes?
Yeah, if you make the iron sheet slanting, it will lead to easy dropping of water to the ground, but make it less slanting, it will hold the water.
Okay. In terms of gradient, which one are you referring to? The one that is high or the one that is low?
That is high.
Okay, Gloria has tried to explain, but network has not allowed, but she seemed to have the knowledge here that, of course, when you make it too slanty and so on, how water flows is it's what she was trying to explain here. Yes, Matthew, have your say. Matthew, I will take the opportunity away. Let's hear from Vanessa. Vanessa, please talk to us. What is your view? Quickly, Vanessa, we don't have time. Vanessa, or I give chance to Santos if Vanessa is not ready. I told you to put up the hand if you are ready to talk about this roofing. Vanessa, please accept to open the microphone, or else I get back to. There is a person who has named the microphone DD. I mean, DD, this is who? Please tell us your name.
Yes.
Yes, DD is what? DD, please tell us your name. Okay. She can't talk, but the activity is here. Why do we build iron sheets? Iron sheet roof with a slope instead of making them perfectly flat. Imagine if we made them perfectly flat. There is an activity here. Why do we build iron sheets roofs with a slope instead of making them perfectly flat? This is to help you know that bit of the slope. What happens to the rate of water, of the rainwater, if we make the roof steeper? Someone digest that and try to summarize this up, and we talk about the mathematical calculations about this gradient. Maybe I give chance to who here? Let me see. Yes, Ivan. Ivan, you can explain to us why do we build iron sheet roofs with a slope?
For me, first of all, mathematically, why we build roofs with slope, just with the name a slope, that means you're increasing the gradient, you're raising it at an angle, maybe 45, the way I can see that one. So when you increase the slope, that means you make the flow of water very much easily compared to the flat roof, whereby water will remain in one place or will be collected. Remember, it's going to be pulled down. When we look at the roof, it's going to be pulled down sometimes by gravity. But when you make it flat, that means you're going to balance it, and then there will be no force acting on it. But when you raise the roof at an angle, whereby you bring out the concept of the slope, that means the flow of water from the rooftop downwards, the building, it will be so fast. That's all I can say, Master.
Okay, thank you so much, Ivan. And that is to do with slope and steepness. And this concept in mathematics is called the gradient. And when we talk about gradient, we look at how steep a path is and which direction is it going. We are going to see how to calculate the gradient. We are talking about the equation of a straight line, and the gradient is going to be very, very vital here. You need to know what gradient is. You need to know, if I give you a gradient, if you're to climb on that gradient, is it steep or it is not steep? Is it easy to climb or it is not easy? And we are going to use lines to demonstrate, is this line steep or it is slanting? And you must use a mathematical formula to tell us this gradient. This is knowledge that you learned in primary. We're going to go through this very fast. Then we go to scenarios that relate to gradient and so on. We see if you can use this knowledge to solve several societal problems. For example, if you're making, there are those people who love to what? There are those people who love to skating, where you have to, and you may be looking at a road that is steep and slanting. You need to explain to us using the gradient mathematically, and even just on the look of the eyes. When you look at this, who is going to reach faster and why? And if we give you time, can you calculate that and confirm to us using mathematics? It's what we are going to look at so much here. So make sure you understand the gradient, relate gradient to the slope. And gradient in mathematics, we are simply attaching a measure. So gradient is going to be a number that will tell us how steep a path is and which direction it is taking. Of course, when it is negative, that one is very easy to slope. If it is positive, it is steeper. And when it is not very big, you know that one is a bit easier, and it's what we'll talk about majorly here. And this topic is, we need to write down for those who have where to write. The topic is equation of the straight line, and the theme is patterns and algebra, the competency. If this lesson ends or if this chapter ends, the learner should understand and use linear equations and their graphs. So what is it calling? Students should be able to use linear equations. Someone told us about linear equation, and she said it is written as y is equals mx plus c. And then Ivan came in, I think it was Ivan, and explained that y means this, m means this, x means this, c means that. It's what we're going to concentrate on in this chapter. So you should be able to write that equation, and you should be able to draw these graphs. If you've got your gradient is negative, you should be able to explain to us that why is this negative. You should not just write numbers and leave them for us there. Please take a screenshot of the learning outcomes. These are 5 of them, and your activity of integration will come from the 5. They will combine the first, second, third, fourth, and the fifth, and give you an activity of integration. It will be marked and scored out of 3. Do you get 3 out of 3? Will you get 2.3, 2.5? My prayer is that once we finish this topic, you should be able to get 3 out of 3. So this afternoon, what we're going to concentrate on is the gradient. Once you know how to get the gradient, you know how to explain the gradient, you know how to interpret the gradient, especially when it is a decimal or it is a positive and so on. The moment you know how to do that, then we'll go ahead and write equations of the straight line. For this, take a screenshot because we're going to move very fast and go to the mathematics of gradients. So gradient in mathematics is abbreviated as letter M. Please put it in bracket. After gradient, put M. This is M, or some books abbreviate it as L, meaning it is the slope or the gradient. So once you see M, just know they are referring to the gradient. Once you see S, still it is referring to the slope or the steepness of a situation. It could be a ladder, it could be a hill, it could be a road. That is called the gradient. And please note that it is always found mathematically and it can be interpreted. Take note of the following. Please write this down. Take note of the following. There are 3 of them. The first one is that when the gradient is a positive, for example, if gradient is maybe 2 or 3, if the gradient is maybe 2, 3, or 7, or 10, and so on, if the gradient is positive, then that line is like this. I'm assuming this is A and this is B.
Hold on.
Let's close the microphones. If the gradient is positive, this is what it is meaning. 2, 3, 7, and so on. It means it is going up. What do we expect when it is in a positive sense? How does it look? The line goes upwards as you move to the right. Doesn't go downwards. The moment the gradient is positive, the line moves upwards. The moment you find your gradient and you realize it is positive, then that line is going upwards. And in real life, the feeling, if you're walking on that line, it looks like you're walking up a hill. So I want you to imagine whenever we get a gradient that is positive, imagine you're climbing upwards. If the valley is too big, then you're climbing a place that is too steep and it is hectic to climb and so on. That is the gradient when it is what? Positive. Maybe before I go to the negative gradient, I'm going to show you, but I'll put down, of course, all your hands and give chance to whoever has a question to put up their hand and ask. If you've not understood that first one, then I will go to the next one very fast like that. Yes, Violet? Violet, please, we don't have time. I'll drop the chance from you. Violet, please ask. Violet is not ready. St. Mark College, yes. Priscilla.
Teacher, does the positive also depend on the signs that you're using, the less than or equal that or equal to?
I've not understood that question. Does the
Do they also depend on the symbols you're using?
which symbols are here? First remind me the symbols. The positive are meaning any value that is above 0. That is positive mathematically. Any value that is above 0 is 1, 2, 3, and so on. Maybe the symbols confuse you.
Yes.
You've understood it?
Yes, teacher.
The positive gradient means any value that is not 0, and so on, maybe 2, 3, 4, 5. That means that line is going upward. And if you're walking on such a line, you're walking up. If the value is so big, then that hill is steep. That was it. The next hand is from Zeish. This is another hard to pronounce. Zeish, please go ahead. Zeha, or how do you pronounce that name? Please open your microphone and tell us your name. Or I go to Jonathan. Okay, Jonathan, please ask your question.
So in this context, it means that as long as it is positive, meaning the more positive it is, it means that the steeper the line is, right?
Correct.
Okay, thank you.
We are going to see that. Please get ready to tell us whether that line is too steep or not. Vivi, please. Vivi has gone off. Then I think we can leave it at that. Let me put down your hands. Okay. That is when it is positive. When it is negative, someone should get ready to explain. When it is negative, it means this value is from -1, -2, -3. How does that look? I know someone can have an idea, of course. When it is positive, it is going up. When it is negative, yes, someone who is using DD. Can I know your name? DD? DD, can I first know your name?
My name is Daphne.
Daphne, which school is this?
It's Namagunga.
Daphne. Yes, please go ahead and explain flat negative gradient.
So for a negative gradient, the line moves downwards towards the right, towards the left.
Okay, the line moves downwards towards the right. Daphne, I'm going to put a pen on your screen. Pick it and draw for us a negative gradient. Just draw it. Use a red color. Whether red or black, provided we're able to see. Get ready, you're going to see. And please, whoever I have not given chance, the moment you pick that pen and draw, I am going to remove you from the meeting. I'm giving Daphne this chance for one explaining. And for if you want to maybe also draw, I'll give you a chance at the later time. Daphne, I don't know if you've seen the pen.
Yes.
Okay, pick it and draw. Pick it, pick a red color and draw for us a negative gradient. You were telling us it goes as if it's going down. Yeah, so put for us, where is it starting from? Going where? Put A and B. Where is A, where is B? To explain what you're talking about. Whoever is writing, you're risking because me, I remove you. That is A and that is B. Good. I will maybe assist you, make it better from this side because of the nature of the phone. Probably your holding could be slightly small, or maybe the experience you're not used to writing here. Okay. She's telling us that he's moving from A to B this side. Go ahead and explain your point now.
So my point is for this line of the negative gradient, we consider that the line, if we calculate it and it's a negative, we find out that the line is moving from A to B towards the left.
Thank you, Daphne. I think that is correct. Let's try out something. We need now to try and see what we are talking about. But of course, when it is negative, then that line is going downwards, like Daphne has told us, and it moves to the right, downwards like this. And she has told us it moves like this. But of course, when it is negative, it moves like this. This is still the same explanation she has given us. If this is A, this is B, and that is the definition. And I'm assuming if this is maybe a mountain, the negative gradient normally is when you're sloping this side like that. This is A from the top coming down. She has already explained, I shouldn't even explain that. And what is the feel? Of course, the feeling is that when you're walking down a hill, that is the feel. When you see a negative gradient, please start to feel like that. Then sometimes it is a zero gradient, rarely have zero gradient, but I even explained to us a zero gradient. You remember when he was telling us that when you make your roof not to have a slope completely, then it will be perfectly horizontal and water will remain there. It will not go anywhere. Perfectly horizontal. The moment you make your roof perfectly horizontal, then you must look for ways of how water will go away, or else the roof will rot because water will never have where to go. And of course, if you're walking, what is the feeling like? It's like you're walking on the flat ground, maybe in your sitting room. When you're walking in the sitting room, that kind of environment, that is a flat surface, and mathematically we say the gradient of that area is exactly zero. And we are going to see how to come up with this. Please put them down. The first one is when it is positive, the second one is when it's negative, and last it is when it is what? Zero. And maybe I see hands coming up. Let me put down these hands. Put up your hand if you must ask something. Please put back the hand. K-I-A, please tell us your name.
Teacher, this is Alicia.
Alicia?
Yes, from Taiba.
Yes, Alicia.
Yes, now I was asking, based on what Daphne has shared, the line got to different sides because what you drew was a bit different from what Daphne drew. For example, if the is higher, it is from the left going up to the right, right?
Yes.
And if it's lower, it is from still the left but coming down to the right. Is that correct?
Now, what happens here is that depending on how you're looking at the line, the definition was looking at it in one sense. It was looking at it going to the right. But what I realized is that Daphne had drawn for us that one that was going to the left, and she's correct. And what makes Daphne's definition correct is that she drew it like this. If she had put A this side, that would mean a positive gradient. But Daphne was very careful. She put her A up here. That one means if at all you were climbing this hill, maybe you climbed from this side, and this is a positive what? Gradient, and she sloped like this, and this is in the negative sense. So she was right, only that the definition I had here had the right bit, and that was to just give you a guide of how the line was sloping. Otherwise, what made her definition correct is that she put the A up, and it showed that she was climbing down.
Thank you.
Yeah, she's right. Provided you're sloping down and you're starting from up, coming down. The moment you start from up, coming down, then you're in a negative what? Gradient. And when you're moving, for those who come from Bali here, it feels good climbing down than when you're climbing up, you'll sweat. But when you're coming down, even the breathe is a bit okay. Maybe if it is again too steep, is when you'll feel a lot of pain, but it is always easy. So when it is zero, when it is zero here, when it is zero, it is flat. And I think no one has a question on when it is zero. Let me see hands here if there is any. Alicia has also put down the hand. Okay, when it is zero, it is flat. So I want us to try out a calculation here, and the activity is please get somewhere and draw. You don't need to draw this on a graph. I mean, if you have a graph book, unfortunately, I didn't prepare you to carry, but I wanted you to plot for me these 2 points. Plot a point 2, 6, and plot the other one, call it B, and let it be 5, 12. 2, 6, and plot the other one to be 5, 12. I was trying to plot it here. Let me see if it is still here. I was trying to plot it here, but it is not really good. It's not on a graph book. For those who have graph books, please go ahead and plot this. If you don't have a graph book, please draw an axis, label it very well, plot. I want us to use that to make a calculation and confirm whether this is positive one, or it's negative, or it is zero. And if it is positive, explain, is it going up or going down, or it is flat? We want to start by plotting, and when you finish to plot, maybe let me also attempt to plot here, such that you plot, I plot here as well. So I'll maybe just draw something simple here. This is 2. This is 5. I have very many here, but the last one is 12. Up, and maybe this one is 6. Let me call this 6. So 2, 6 is here, and this is point A. Then this is 5, 12 is here, and this is B. This is our line. It's going up or down. If this is going up, I want to just sample. Before you even calculate, is this gradient going to be positive or negative? Let's see in the chart. Please write it in the chart. Is this going to be positive or negative? Put it in the chart. Is this gradient going to be positive or negative? Yes, the chart is open. When you look at that, it is climbing or coming down? Yes, it's positive. Everyone has seen this. That is good. Okay, I've not seen I've seen Petros is telling us negative, but majority of the people say it is positive. Okay, I'll close the chat at that. But at least I've tested, people seem to have followed. This is going to be a positive value. And how do you get the positive value? We count how many steps have we moved horizontal and how many steps have we moved vertically. And what we do is this. We are going to get, someone talked about the change in values, change in X, change in Y. I know you already have this idea. Can I get someone to give me this gradient? Please solve for us this. Anyone who has finished, or maybe even when you've not finished, but you can give us this answer. Maybe you've ever read it somewhere before. I can show you this working. Let me put down the hand and give chance to whoever is ready to take us through this, if at all they want us to get the gradient of this line. Anyone who can get? Okay, Ivan, please. I want to see if you can get this right.
Okay. If you are to get the gradient, since they have given us the points A and B, so we shall use this formula as let the gradient be M.
Yes, M.
Whereby M will be change in Y out of a change in X.
Yes.
Yes. So the change in Y, we get the Y2 minus Y1 out of X2 divided minus X1. Yes. So our Y2 will be the points at B. So that means at our Y2 we shall have 3 as our Y2.
We shall have what?
We shall have 12 minus 6 out of 5 minus 2. Yes. So 12 minus 6, we definitely remain with 6 out of 3. And that 6 out of 3 is divisible. That means our final answer will be 2. So our 2 will be our gradient.
The gradient is going to be 2.
And it is a positive.
Okay, he is telling us the gradient is going to be 2 and it's a positive. This is correct. We need to explain this maybe more. But yes, thank you, Ivan. He has summarized it for us. I'm going to put down the hand such that we can attempt to explain this. Now, when you look at this, Brian has told us you need the change in Y, you need the change in X. Now, when you're given the coordinates of A, which are these, the coordinates of B that are this, how do you get the gradient? Or how do you know whether the gradient is steep? Or how do you know whether it's positive, 0, or negative? These are the questions you ask yourself. The first question is, how many go up vertically? How many steps? And how do we count these steps? For those who are using the graph book, which of course I did not tell you to carry, for those who have carried well and good. If you've not carried, this is what we are talking about. From 6, which is our line. Remember, this our line is somewhere here. How many steps did we go upward? You count. 1, 2, 3, 4. You're going to find 6 steps here. 6 boxes for those who have drawn it correctly. Let me maybe use a straight line here and try to explain that. How many steps did we go up vertically? So remember, this is 1, 2, 3, up to 6. This is 1, 2, like that. Then here I'm going to count 1 up to 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from 6 here, this height here, maybe if I can demonstrate it from this side. This is the height, maybe I can call it h, is this question here. How many steps did we go up vertically? And for those who have used the graph, you realize that if your 6 is somewhere here, I'm assuming this is 6, our height is at 12. 6, 7, 8, 9, 10, 11, 12. 12 is here. So if you're using a graph book, please count these boxes that are in between 6 and 12, and you realize that they are 6, 1, 2, 3, 4, 5, 6. There are 6. I've added 1 here that was not part. Starting from here. Please count those boxes. There are 6. And that is the question. How many steps did we go upward? And that is the height. It is the 6 you're seeing here. And how do we get the 6? We get what they call the change in y. So it is going to give us a formula that Ivan has used, which is change in y over change in x. And how do you arrive at 6? To get the value that is up and take away from the value that is down here. And of course, maybe let me try to explain this on a clear screen. Okay, sorry about that. My network went off here, and I was trying to show you how gradient is arrived at, and I'll start from there immediately. Okay. I was looking at the formula of the gradient vertically and horizontally, and Ivan had already explained to us how he got his answers too. And horizontally, for those who have drawn that on the like I had requested, you realize that your horizontal line looks like this, and maybe there is a 2 here, and there is a 5 here. 1, 2, 3, 4, 5. 5 is around here. So the distance from 2 to 5, how do you get that distance? From 2 to 5, please count what is here, the boxes. You realize there are 3, 1, 2, 3. So the vertical distance here we had got, the vertical distance here we had got 6. The horizontal distance here we had got 3. How do you get 6? How do you get 3? Ivan explained to us that you get 12 and take away 6 and divide by, you get 5, take away 2. Why do we use 12 take away 6? Why do we use 5 take away what? 2. It's because we want to get the horizontal distance, and here the horizontal distance, the vertical distance is 6, and the horizontal distance here is 3. How do you get 6? I explained. How do you get 3? I have explained that you count the small boxes here, and the easiest way to get is getting the last value that is here, which is 5, take away the lower value that is here. And he summarized it and said, if this is A, this is B, If this is A, this is B, get one of the points, call it 2. And this is how you can easily understand this. I'm calling this 1 the first coordinates. I'm calling this the second coordinates. So these coordinates, you remember very well in your senior one that this is X, this is Y. This is X, this is Y. So in your senior one, you learned that these coordinates are X and Y. So when you call this points 1, this is point 2, it means all the values that are in point 1 are going to be X1 and it's going to be Y1. X1 means the first coordinates of this line. Y1 means the first coordinates of this line, the first Y coordinate of this line. Then these ones that you called 2, we will have X2 and we will have Y2. This means X2 means this is the second coordinate of this line. This is the second X coordinate for this line, and Y2 means this is the second Y coordinate of this line. And you had to put them here much as I have treated that. So when you're determining the gradient of the line, this is the formula you saw in primary, and it's the one we are going to build on this afternoon. The formula says you get the change in Y and you divide it with the change in X. And in other words, that is Y2 minus Y1. I have explained where Y2 comes from and where Y1 comes from. And it's what Ivan had talked about earlier. So please put this formula down. It is very important. We're going to use it to get solutions to many problems. The first thing you do is to put this formula down. The formula says if you're getting the gradient or you're getting the slope of a line, to see if it is steep or it is slanting, get the change in Y over the change in X. And when you're getting the change in Y, it is always the bigger value, take away the other one, and so on like that. Then go through the mathematics and see what is the final answer you get. If it is negative, it is slanting. It is coming downwards. If it's positive, it is going in the upper direction. And we're going to, please take note of this formula. We are going to use it to solve one example or two. Then we will leave this probably. Then we'll start from there on Friday next week. Of course, there will be hands. I've seen one hand. Elvis seems to ask something. Yes, Elvis, please ask before I can display the example here. Elvis is not ready. Please, Elvis is not ready. We may not have, there is something you've not got well. Please wait in the example and see maybe if it can be brought out. There is an example here that is saying, find the gradient of the line that passes through the points, that and that. This is going to be easy. And this is what I was saying. Please start by quoting the formula. And our formula is that gradient of a straight line is always m is equals change, and change is written like this: change in y over change in x. This is the primary knowledge, and this is the same as y2 take away y1 over x2 my 2 is not seen, x2 take away x1. So how do you get x2? How do you get x1? Please, these coordinates that have been given to you, give them names. I'm calling this 1. I'm calling this 2. So my x1 will come from here. My y2 come from here. All the values that will have 1 will come from here. So this will give me the x1. It will also give me the y1. Those are the first x coordinates and first y coordinates of this line. This one will give me x2, and this will give me y2. For those who know how to substitute, please go ahead and put your answers. I want to see the answer in the chat such that it is able to tell us whether you got this or not. Now I'm going to substitute. Y1, I'm substituting these values here. This is going to be the same as, this is now going to be 6, which is my Y2. This is Y2. This is X2. This is X1. This is Y1 like that. So this is going to be 6 take away 2 over, this is going to be 3, take away 1. This will give us 4 out of 2 to give us the answer as 2. And this is how we get the gradient. So the gradient for this line is going to be 2. I want to see if maybe in the chat people have the same answer or you're getting a different answer. Please post your answers in the chat and we see. For those who tried it out and got the M values as 2, or maybe you got a different one. Joan says it is 2, Daphne is 2, Ivan is 2, yes, and so on. Good. I am going to receive the hands on the next exam because we have so many examples to go. So the fact that some people have 2, we can proceed for now. And we look at the next question, then I'll give chance to whoever is asking. Those who have tried the first question and you've got the answer, please try out the second one as I receive the answers. As I receive the questions from people. I'm going to put down all your hands and put up the hand if you must ask something. Put your hand up. Put your hand up and ask a question. Or, yes, Santos?
So, sir, when I look at the gradient or the y2 minus y1, like it's like it's like the opposite. For example, here they have said find the gradient of the line that passes through the points A1, 2, and B3, isn't it? So we find it that we take 6 minus 1, isn't it? Out of 3 minus 2. Sir.
I've not got that, Santos. I beg your pardon. It is 6 minus 2.
Minus 2 out of 3 minus 1.
Yes.
Yeah, you're right.
That is how we do it. Any other question?
Okay.
Those in the chat, please post the answers. Let me open the chat for you to post the chat, the answers. Yes, Santos, was that what you asked? Is there any other question?
Because if I see this second number, isn't it? Find the gradient of the that passes through 0.00448. It will be 4 minus 0, isn't it? Out of.
Are you starting with X or Y?
Minus B.
You're starting with X or Y?
I'm starting with Y.
Y is what? Is Y 4
Y is is it 8?
Yes, please try to look through and remember those coordinates. Y is not 4, Y is 8.
Yeah, Y is 8. 8 minus 0 out of 4 minus 0.
Okay, good.
Isn't it?
So, yes, someone is telling us they have got 2 again. Yes, this answer is 2. If you've got 2, please don't get disappointed. That is correct. Yes, Santos, any question? Have you got your answers too, Santos?
No.
Okay. Please put up your hand before we go to what is now for senior theory here. All this is just reminding you of primary. Before we get to senior theory, please ask all what you've not understood. And maybe for those who are trying out, there is another bonus question here for you. Slightly hard. Please try this out and we see what the answer is. Yes, put your hand up and ask as people are trying out. And you should hurry and catch up with other people if you're asking a question. Please, this time round, I wanted you to try to post this answer, but we may not try. Anyone using a book and you're able to take a photo and post on WhatsApp, put up your hand, I see, such that I can open WhatsApp and you post the answers there direct. How many people are able to post on WhatsApp? 2 people. How many people can be able to post on WhatsApp? Okay, 3. Okay, let's open on WhatsApp and post answers there. I want to see for number 3. Anyone who can get the answer, please. I want to see who posts first on WhatsApp. If you've not written on a paper, please get a paper. And when you're writing on a paper, before you take a photo, write your name on top. We should be able to see your name correctly. Such, if possible, the school also. Put your name and put the school. Take a photo. They're telling us to get the gradient of a line passing through points E and F. This is welcoming what you're supposed to study in senior 3, and it's what is coming up next. So when you go to WhatsApp, not again, refuse to come back this side because you're going to miss the senior 3 work. And for those who are not on WhatsApp, I'm sending this link in the chat such that you're able to see. And the WhatsApp group is now open. Let me open it such that you can post your answer. Yes, it is open. Please go ahead and post. And for those who are not on WhatsApp, let me post the link in the chat here. Yeah, that is the link. For those who are not on WhatsApp, please join. And I'm going to be on WhatsApp to see who is posting and what answer is that. But also I want to see for those who are writing and those who are not writing. Yes, we've received the first work. And now this person who has posted has not put the name, but he has got the answer as 3. And that is very good. I'm going to put for you A. Yeah, Angel has already sent her work. This is very good. Angel is getting the answers too. We are going to confirm whether the answer is 2 or 3. Good. This person who did not put the name, please repeat. And then who else is sending the work? Can we see? The answer is 2. I don't want to see the answers 2. I want to see a photo of the answer. No typing. I don't want someone to type the answers here on WhatsApp. Yes, I see these hands up. Sky, why is your hand up? Okay, finally. I'm seeing some work here from Mwevaze. Yes, Mwevaze has given us the answers too, and it is positive. Good. Prissy has told us, according to her, Priscilla is telling us the answer is 2. We are going to see. This is who? No name for this person, but I think it is Ayo. Whoever is just typing the answer, we want to see a photo. This is Alitua Manuela Kevin, Gayaza School. The answer is 2. Maybe Kevin has confirmed the answer now. Okay, the next person here is Good Luck Jonathan Aldosius is from St. Kizito SS, Golobi. The answer is 2. This one, no name. but the handwriting is very good. This person who has given us the answers too, handwriting is very, very good. Who else is here? This is Caroline, Naomi, and the answer is 2. Good. You people, I'm closing the chat such that we get back to class here. Okay, please don't. Okay, I need to close this WhatsApp group because I think we've received most of the answers. We get back to class. I've also seen the WhatsApp a registration link. Please, for those who are able to sign in, please, can you follow that link and register? We need to know your school. We need to know where you're calling from. We need to know your full names at the Holistic E-Learning platform. I'm going to share this link on Zoom such that you're able to register. For those who have sent in their answers, that is good. Please get out of WhatsApp and come back this side to class, and we look at what is said in senior theory. Can we get a volunteer to give us this answer? Show us how you got your answer, as 2 or as 3 or as what. Put your hand up. Santos, you've over given us the answers. Can we get someone else? Santos, yes. Namukose. Namukose, please show us how you arrived at your answer.
So,
yes,
since we have two coordinates, x, so we label the first one x1 and y1.
Yes. Yes, proceed.
Then we label the second one x2 and y2.
Yes.
So now we write the formula. M is equal to change in y minus change in x.
Minus or over?
Over, I mean.
Okay.
So we say y2 minus y1 over x2 minus x1. So 11 minus 5 over 5 minus 2. So we get 6 over 3. And when we divide, the answer is 2. Teacher, 2.
Yes.
Yes, that's it. So we conclude M is equal to 2.
Okay. So if this is a line, is it going up or downwards? This was who was giving us Namubiru. Put up your hand, please, and finish your work. Is this line going up or downwards? Charity, can you tell us this line? Is it going up or downwards? Charity.
The line is going downwards.
It's
No,
going
the line is going
downwards? Why?
upwards.
It is going upwards. Why?
Because it's a positive gradient.
Yes, because it's a positive gradient. Good. So I want us to imagine some scenario questions in senior theory. If you're in senior theory, of course, at the beginning of this topic, you're going to see these 2 questions. Please take a screenshot and finish them. There is question 4 and 5. They are equally good for practice. but because of time, I'm going to skip them, take a screenshot and do them. You'll post the answers on WhatsApp. Allow me go to the next slide. A scenario question. I want to try out one scenario question here. We're going to try it out together, and you're going to help me try to explain this. And I see by show of hands who is ready to read for us a senior theory question. Now leave primary. We want to try out a senior theory. They will twist it a little bit, but you must get the answer correct. So I really want to see a name that I have not seen here. Venus. Venus, you've not talked to us. Venus, tell us your answer. I mean, Venus, you're going to read for us the question. Are you ready? Venus, are you ready?
Hello. Yes, please.
Okay, what is your full name?
It's Nasana Angel.
Angel.
Yes.
Angel, you're going to read for us the scenario, and if possible, you'll attempt to interpret it for us. It's about a gradient, you shouldn't worry. The scenario is here.
A carpenter is building a ramp for a hospital. The ramp starts at ground level, 0, and must reach a door at a height of 2 meters, located 10 meters away horizontally. 10-2.
Yes. So try to, what do you think the carpenter is doing?
Building a ramp at a ground level.
Sorry?
Hello.
Can you tell us what the carpenter is doing in this scenario?
The carpenter is attempting to build a slope, according to me.
Is attempting to build a slope, yes. Maybe there are those people who use wheelchairs in the hospital, and he's attempting to make one. They're telling you that it is from the ground level, which is at 0, and it must go at a height of what? 2 meters. So, read for us the task.
Calculate the gradient of the ramp if the safety limit for a wheelchair ramp is a gradient of 0.25. Is this ramp safe?
Yes, so we want to try out and see if the computer is constructing a gradient or is constructing this slope like Angel has told us. If this computer is constructing that gradient or that slope or what for these wheelchairs to use, we want to determine what is the gradient. Because the question is telling us to get the gradient. And they are now telling us that, you know what? The wheelchairs that are going to use this slope the computer has designed, they have a safety limit for the gradient of 0.25. Now you're going to compare your gradient that you've got and what the wheelchair dictates, and we see if what they have constructed is safe. So can you go ahead and calculate the gradient and put it in the chart? Let's leave it at that. Or maybe if you're writing, you can write the whole of it. They have given us the first point is at ground level 0, and the upper one is at 10.2. Give me the gradient. Post the answer in the chat. What is the gradient there? Please just put the answers in the chat. We try out, put it in the chat, and we see your responses. I've opened the chat. If your answer is ready. I know the gradient, they have also given you 2 points, the ground level. Please, I'm waiting for the gradients in the chat, then someone will explain to us. Okay, I wanted people to get the slope or the gradient of this ramp this computer is trying to construct. Then please go ahead and tell us whether this is safe or not, because they're telling you that, look, these wheelchairs have a safety limit of a gradient 0.25. Now compare your answer with what you have got. Compare your limit of this wheelchair with what you have got and see whether this is safe or not. And because everyone is getting 0.2, I want to see now if you're sure this is safe, put your hand up and explain to us, because we've confirmed that the answer is 0.2. Let me close the chat such that people can concentrate on putting up their hands here. Put your hand and tell us whether this is a safe place or not and give us the reasons. Ivan?
For me, definitely, I say the ramp is safe because when you look at the gradient, which you have got, it's 0.2, and the maximum gradient is 0.25. So when you compare those two figures, you find out that the ramp that the carpenter built is way smaller than the maximum ramp which is required. So the ramp is safe.
Yes, the ramp is safe. Yeah, thank you, Ivan. He's telling us the ramp is safe because it is less than what is required. Let's hear from some other person. Thank you, Ivan. Venus, is this safe or not?
According to me, the ramp is safe because it's within the limit, within the safety limit for our wheelchair ramp.
Okay, and how do you know that it is within the same limit?
0.2, which is the gradient of the ramp, is less than 0.25.
Okay, so it makes it safe. And the correct answer is that since 0.25 is the maximum or the limit, and the value we've got is less, it means this wheelchair can walk on that slope. So if they have written on that wheelchair, the gradient is 0.25. When you're constructing, please make it slower than that. Otherwise, if you make it 3 or you make it 4, that will be too steep, and that wheelchair will be unable to move up. Let's try the second last question, and they are talking about the roof leans a ladder against a house. This is what we started with. Please go through this and let me know if you can get this correct. And the task is calculate the gradient of the ladder. If the ladder is only stable, if its gradient is exactly 4, is this ladder positioned safe? Is this ladder positioned safely? I want to know if that ladder has been positioned safely. They're telling you that the ladder is only stable if the gradient is exactly 4. Let me know if this ladder has been positioned well. Please go through this very fast and we get the answers. After that, please make sure you register. I'm going to sign this link. I'm going to send this link in the chat such that please click to register. Put your name, put where you're coming from, answer those questions, because we need to know where you're calling from such that we know who you are and maybe how was the lesson. Please put your comment there. Let us know that you attended and this is what you got as feedback from. So I'm going to post this link in WhatsApp, but also I'm going to post it here, such that you're able to tell us, give us that feedback. I've posted it on WhatsApp for those who are on WhatsApp, but don't now go away from the meeting to go to WhatsApp. But also I'm putting it in the chat here such that you can register. Please register after the lesson because it may remove you out of the lesson if you accidentally register and maybe you don't know how to come back. I did not check in the chat, but people were telling us, Angel had told us it is not safe. No, it is safe. And who else had told us? Favor told us the ramp is safe. She was very sure. Someone using a Samsung S.3 IV, it was safe. And now they told us it is safe since the limit is above 0.2. Okay. So I'm waiting for this answer. Start by getting the gradient and let me know if the ladder is stable. Is this ladder positioned well? I want to hear from someone. Please put your hand up and tell us whether this ladder is positioned well. I'm going to lower the hand such that you put up your hand only if you have the answer. Put up the hand again if you have the answer. I want to know if this ladder has been positioned well. I still want to give chance to Vanessa has not talked to us. Vanessa, tell us your name and where you're coming from, then tell us if it is positioned well. Vanessa, which school is that? Vanessa, please. Vanessa is not opening the microphone. Okay. Let me hear from, I still wanted to hear from Vanessa. She's the only one with the hand up here, which we didn't hear from. Okay, Charity, tell us, is this ladder positioned safely?
This ladder is positioned safely because the gradient is 4.
The roof has positioned it safely.
Yes.
Okay, please confirm that the ladder has been positioned safely because my answer here is correct. The ladder was positioned safely because the gradient is 4. Anyone with the correct answer as 4? Let me put down everyone's hand and see how many people got the answer as 4. Your hand up.
The answer is 4.
9 people confirmed that their answers is 4. And you can only know if the answer is, you can only confirm that it is positioned well if your answer is 4. I want us to leave this here. Put down your hand, and I want to leave this exercise behind for you to try out. There are 2 questions. Take a screenshot, and when we come again, we are going to write the equation of the straight line. Please have a good evening. Please take a screenshot of this. Try out these 2 questions. Post the answers on WhatsApp. I'm opening the WhatsApp group at 6. Try, get the answers, write your full name and the school. Take a photo, a good photo, and at 6, exactly 6, I'm going to open the WhatsApp group. I think let me open it at the, yes, at 6. Let me open it at 6 and post your answers. Question 1, question 2, both of them are compulsory. Go ahead, do them, and confirm if what you've got is correct. The first question they're telling us, confirm if the pipe is set correctly. Second one is that, is this slide safe? There is a person here, there is a father trying to build a slide for the kids, maybe to play on it. And they've given you, they want you to tell the gradient and advise whether the slide they made is safe or not. So we will leave it here for now, and I'll put down all your hands, and you put up your hand if you have a question. And if there is no question, we'll leave it here for now, and maybe we'll get someone to give us a closing prayer. Any question? Yes, Ivan?
I'm not really a question, was just giving the closing prayer.
Okay, maybe Ivan, you've booked for the closing prayer. I'll give you a chance. Ivan, give us the closing prayer. Okay, put down your hand and I hear the questions if they are there. But you'll come back for a closing prayer. Someone using Samsung S34? Your name? Someone using Samsung S34? Okay. Any questions, please put up your hand and ask if it's there. If it's not there, I ask Ivan to give us a closing. Okay. Ivan, please get back and give us a closing prayer.
Okay, let
Ivan
us
can
have
proceed.
ourselves and we pray. Heavenly Father, I want to say thank you, my Lord, for your blessings, your mercies, oh Lord, all over us. You made us run from Monday up to today, my Father. We are still here, looking for what can benefit our future, oh Lord. But above all, we put you in our education. We put you, oh Lord, in all our activities, be it academic, homework, oh Lord. My Father, all our activities. May you come and support us, provide us with the wisdom, O Lord, and above all, support parents financially, such that they can also support our academic journeys. I pray this in the name of the Father, the Son, and the Holy Spirit.
Amen. Thank you
Amen.
very much. And we type amen in the chat as you go. Believe in that prayer. Let's leave it here for now. Have a good evening. Have a good night. For those who are traveling, have safe journeys back home.